In this video we're going to talk about muscle fiber types, probably one of the topics that we talk about in anatomy that people get most interested in because it can be relatable and applicable to what you're doing. So hopefully you will find the same. If this seems a little confusing at first, that's okay. Understand that in class we're going to be doing a lot of activities that will be digging this stuff in and drilling it into. So we will definitely be spending time in class practicing all the information on muscle fiber types. So listen to the video, come to class, and we'll spend time with that. Same thing as I've talked about in other videos. As a reward for watching this video, you're going to get your name into the drawing one more time if you send me an email telling me what your favorite exercise is. Okay, so send me an email, allison.belay@Bryan University. Tell me what your favorite exercise is, and your name's going to go back into our drawing another time for all of our prizes. This module sounds like a game show host. Alright, moving forward with our slow twitch muscle fiber types. So, slow twitch muscle fibers. Let me back up just a little bit first. Let's go back to our muscle structure that we looked at if you've watched that video. And remember to visualize that our muscle fibers are actually muscle cells bundled together in little bundles to form a muscle. Understand that all of us have a combination of slow twitch and fast twitch muscle fibers. It's the activities that we do that determine which type of muscle fibers we are predominantly using. Understand that oftentimes students will think that we're either using slow twitch or we're using fast twitch, and there's no in between. But it's really a spectrum. We're using a mixture. So it's really more which ones are we using more for a certain activity. We're rarely just using fast twitch fibers, and we're rarely just using slow twitch fibers. We might just be using fast twitch fibers when we're sprinting full out or doing a power lift, but understand that it's a spectrum that we'll talk about in class. So, slow twitch muscle fibers are the muscle fibers that we're going to call on whenever we're doing an activity of lower intensity, long duration. So if you look at our marathoner on the left, he, in that moment, most likely, depending on where he is and how exhausted he is primarily calling upon slow twitch muscle fibers to get him through the race. So if you haven't watched the energy systems video, this won't completely make sense to you, but when we are in any type of endurance activity, we are in our aerobic system, okay? Meaning we need lots of oxygen flowing to all of our muscles to keep us going, to help generate ATP. So, some of the characteristics of slow twitch muscle fibers are they're higher in capillaries. What does that mean? Capillaries are little structures at the end of our arteries, and we have our aorta, and then we have our arteries, and we have arterioles, and they just keep getting smaller and smaller until eventually we get down to capillaries. And capillaries is where the oxygen basically jumps off the blood wagon and pops onto the effector site or the muscles. So basically your blood carries oxygen, and as it reaches the muscle, it diffuses across those capillary walls into the muscle. So the more capillaries we have, the more availability of oxygen to that particular muscle. So one of the training effects in the body of cardiovascular exercise is that you actually increase your capillary system. So the more you do an endurance exercise, you kind of make your capillary system grow, therefore more oxygen availability, and as we'll talk about in the future, that's opportunity for higher VO2 max. Also another characteristic are the mitochondria. Mitochondria are a cell structure where ATP is produced. That's our energy currency that we're going to talk about in our energy system video. So really important, the more mitochondria we have, the more availability to produce ATP. The more ATP we have, the longer we can keep going. We'll talk about myoglobin in class. I'm going to skip over that. So another characteristic is they have an increased oxygen delivery because of this higher capillary capillary system. They're smaller in size, so as you look at your marathoner, he's lean, so he has a lot of slow twitch muscle fibers, but they aren't large because they have endurance capabilities. So they're smaller and they produce less force. When they produce less force, that means they can go longer. So they're slower to fatigue. So lots and lots of slow twitch muscle fibers, but because they don't produce a lot of force, they produce more of an endurance characteristic. They're going to be smaller and they're slower to fatigue. Now on the opposing side of the picture, you see our big sprinter guy here, and so that he's a good picture in your head of what might constitute a fast twitch muscle fibers. And so fast twitch muscle fibers are opposite, and I like to kind of think of fast twitch muscle fibers is like a little kid. You know, they go, they go, they go, they go. They can go everywhere. They have all this energy, and then bam, they're just done. There's just nothing left. They just, you know, Tasmanian devil right there. Slow twitch is more like adults. We kind of, you know, a little more endurance. We can get a lot more done. We're not quite as not as hyper as our children, right? So the type 2 fast twitch muscle fibers are like those little kids that just go, 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 and then they just kind of drop. So they're lower in capillaries. So when there's two types of fast twitch muscle fibers, which we'll talk about in the next slide, type 2A and type 2B. But in particular, the type 2B muscle fibers, fast twitch, are lower in capillaries because as you learn about the energy systems, you'll learn that when we are sprinting or calling on our fast twitch muscle fibers, oxygen is usually not a factor in producing ATP for us. So they have fewer mitochondria and same thing, lower myoglobin. They have a decreased oxygen delivery because once again, when we're truly using fast twitch muscle fibers, we're not relying on oxygen to create ATP. We're relying on other things such as our stored glycogen and our available ATP. So opposite of the slow twitch muscle fibers, they're larger in size because they produce more force. So if you were to do a muscle biopsy, you would see that the fast twitch muscle fibers are larger than the small twitch. So they're large, they produce great force, but they can't keep going. They're very quick to fatigue. That's why we call upon them in very short bursts of exercise. So breaking it down a little bit further, if you look at our fast twitch muscle fibers, we've got type 2A and type 2B. So we just talked about the type 2B muscle fibers, fast twitch, fast glycolytic, meaning any kind of power lift, a very fast sprint, anything where you are doing it very, very quickly and very, very powerful, you're going to be calling upon your type 2B muscle fibers. Going to the other side, we have our type 1 muscle fibers, as we talked about, and you're doing low intensity, long duration, right? You're calling predominantly on your slow twitch muscle fibers, cycling, jogging, things like that. The interesting thing is almost everything else we do, we're predominantly calling upon our type 2A muscle fibers. They're the intermediate fibers. They have some oxidative qualities. They're kind of known as the jack of all trades, master of none. So they don't master sprinting, they don't master in low intensity, long duration, but they do everything in between. So most group exercise classes, most of the time, and depending on what you're doing in CrossFit, boot camps, weightlifting where you're doing, you know, medium to higher reps, those are all predominantly called on by type 2A muscle fibers. So we will definitely discuss this in class and practice which types of muscle fibers do what in greater detail when we get back into class. But this is just one more one slide showing you just a table of the different characteristics of the muscle fiber types. And it's just showing you here that the type 2A have those oxidative capabilities because they are at some point sometimes calling upon oxygen to help fuel their intensity level. Okay, so same thing as you'll see type 1 and type 2A, they have mini capillaries because there is oxygen involved, whereas in type 2B, when you're sprinting or powerlifting or whatever, no time for oxygen, so they have very few capillaries, all that kind of good stuff. So we will discuss glycogen in another slide, so I'm going to leave this one right here.